First question is use the equation and corresponding graph for the quadratic function. So basically, you're using transformations. Okay. Uh, do we need to go over that at all?
We could.
Okay. All right. Let's do
I
that.
mean,
Okay. You have y equals to, we're going to just use x squared. Y equals to x squared plus k, or y equals to x squared minus k. This is going to make the graph. If you start with the parent graph of y equals to x squared, and that's a parabola. Okay. Oops. So
got it.
it looks like this. Okay. So this graph, when it's x squared plus k, it's going to move the graph up k units. If it's x squared minus k, it's going to move the graph down k units. So if we have a graph like y equals to x squared plus 5, let's say, okay, this graph will shift up 5 units. So it'll be 1, 2, 3, 4, 5. So now it looks like that. Okay. So if it was minus, then it would shift it down. Okay. If you have y equals to x squared, or x, let me rewrite that. You have y equals to x plus k, or h units, we'll call this h, then it's going to shift left h units. So, and if you have y equals to x minus h, parentheses squared, then it's going to shift right h units. So if it's inside parentheses, it's right or left. If it's outside of parentheses, like plus or minus, then it's up or down. So inside parentheses, it's opposite of the sign. So if
Okay.
you have y equals to, let's say, x minus, let's say, 3, then that's going to shift it to the right. That's going to shift our parabola to the right 3 units. Okay? And if you have something like this, we have f of x equal to x minus 4, parentheses squared, minus 1. So this is f of x equals to x minus 4, parentheses squared, minus 1. Okay. Then inside parentheses, it's going to make it shift 4 units to the right. And then this minus 1 is going to make it shift 1 unit down. So it's going to shift 4 units to the right, 1, 2, 3, 4, and 1 unit down. So now this vertex right here, the lowest point on the vertex, is going to be his shift right and then down.
Okay.
And it's going to look like that. Okay?
Got it.
So we've used table of values before, but this is transformation, and it's a lot easier and a lot faster to know how to use transformations to graph a function. All right.
Right.
Okay. Now, if there's a minus in front, it's going to flip it. And so one more thing, it's asking for the domain and range, right?
Right.
The domain for all the parabolas is all real numbers, or negative infinity to infinity. Let's see which way they. And so you can either use set notation or interval notation. Let me see what they're using here. Okay, they're using interval notation. So it's negative infinity to infinity, and then the range is going to be this is h, k. So the vertex is hk, so this would be 4 to the right, 1 down. So the range is going to be the k part, where it goes up and down. So this is -1, so it's going to be, and since it's moving up, it's going to be closed at -1 and up to infinity.
Okay.
Okay, so it always uses the k part, the part that's outside the parentheses. And if it's up, then it's going to positive infinity. If it's moving downwards, going to negative infinity. All right.
All right.
Okay, so let's look at the next one. Okay, this negative is going to flip it. All right, and so let me rewrite this. F of x is equal to -2, and then parentheses x minus 3, close parentheses squared, plus 5. Okay, so they show the graph. They already show the graph. So this is going to move right 3, up 5, and this is going to reflect or flip about the x-axis.
Okay.
2 is going to make it vertically stretch, but that really doesn't affect domain.
Right.
So here's our graph, right? And so this point is 5, and this is 3.
Right.
So this is, so you look at what makes it move up or down, right? And it's going, this time it's moving downward.
Right.
So the domain is always going to be negative infinity to infinity for a parabola, for the ones we're doing. The range, because it's moving down, it's going to start, it always goes from most negative to most positive. Since it's going downward, this is going towards negative infinity. So this will be negative infinity to 5. And it's always closed because this is the definitive point. So it's going to be closed for range. Okay?
Okay.
So you always look to see what the number is, moving it up or down, and see if it's moving, opening up or opening down for your range. All right? Any questions?
Got it. No, I don't have any questions right now.
Okay, so any questions with number 3?
No.
Okay. How about number 4.
Let's see. This is actually the stuff I did on homework, so I'm actually getting used to doing it and getting better at it. Actually,
Good. Okay, so we good with 4?
yeah, we, yeah, I think 5 might be a little confusing. No, 6 is
Oh,
6. Yeah,
okay.
but it's the fraction that messes me up sometimes.
Yeah. All the fraction means is that it's vertically compressing. So in other words, it's opening it up. So in other words, if you just looked at y equals 2 1/3 x squared, all
Right.
right. Well, here's the parent graph y equals 2x squared. All right. So parent graph when x is 1, well, 1, if you put 1 in, right, for x, well, 1
Mm-hmm.
squared is 1, so it's 1 in, 1 out, right? And negative
Right.
1 is going to be negative 1 in and 1 out. Well, when you have a number in front here, if it's a fraction, instead of being at 1, 1, it's going, now your graph is going to be at 1, here's 1, 1, 1, 1/2, and
Okay.
here's negative 1. So it vertically compresses. So it looks like it's widening out. It looks like it's widening out. Okay.
Okay.
So, and that's all it does. Let me let Trent in. Hi, Trent. Let me get you in here. Wagner. Trent. Oh, here we go. Robinson. Oh, did I lose you?
I think his audio is connecting. Yeah, he's in.
Um. Oh, Jalen. Okay, Jalen Robinson. Here it is. Okay. Okay. So really, that don't let that throw you off, because it's really not going to change the graph that much. So if you have y equals negative 1/3 x plus 2 squared minus 3, I always, well, this is going to reflect, right, or flip,
Mhm.
and this will be left 2 and down 3. So I
Right.
always like to start with knowing that it's going to be down, and this 1/3 means it's going to compress vertically by a factor of
Gotcha.
1/3. So this will be left 2, down 3, and it's going to open down. So whether this number is really, all it's going to do is widen it out, but everything else is the same. Okay. So does that help?
Yeah, that helps.
Okay, good. Find the domain and range. So basically, domain's always going to be negative infinity to infinity. So the range, you look at that, right? And you look at, see, is it opening up or down?
Looks like it's probably gonna open up,
Yeah, it's
right?
going to open up, and it's up 8. So basically, it's
Right.
just 8 to, domain is going to be negative infinity to infinity, and range is going to be 8 to infinity. Okay.
Right.
So you just look at that outside number. If there's no number there, then it's at 0. You would put like plus 0 there.
Okay.
Okay. Find the equation of the axis of symmetry. Do we need to go over that?
No, we're good.
What?
I said no, we're good.
Okay, good. And so this one here, so we're good here too?
Yeah.
Okay. Find the vertex. So don't let that outside number throw you. That just means it's stretching it by a factor of 9. So instead of being at 1, 1, it's going to be at 1, 9.
Okay.
So find the vertex. So you would use, basically, you could use transformation here.
Right.
So do we need to go over that, or are you okay?
The vertex one, yeah, I'm good with that one.
Okay. So it'd just be 2, -8, right? Because it'll be opposite of what's inside. So the vertex is 2, -8. We good there? Because it's going to move right to
Yeah.
down here. Okay. Use synthetic
Okay.
division.
Yeah, I think we did that in class before, actually.
Yeah. Yeah,
Okay.
we did. The only thing about synthetic division is you got to make sure that there's this place for x cubed, a place for x squared. So here, let's see, 4, 3, 2, 1. So yeah, and then here, 3, 2, 1, 3, 2, 1. Yeah, so those are all, nothing's been skipped. So I didn't try to throw any curves or anything like that. So, and you want to go over any of them? The only
I
thing,
think we could go over the. I think we could go over 13.
13. Okay.
Yeah.
Now here, you have to change the divisor from negative to positive. Here, you don't, if it's already given to you, like k
Mhm.
equal to -2, you don't change the sign. Okay, you just start off with -2. So they
Right.
want you to use the remainder theorem and synthetic division to find f of k. So I think all they want is the remainder. Let me see. 13. Yeah. Okay. So um, the remainder theorem basically, here, let me rewrite this. Remainder theorem states that if you have a function f of x and your
Hmm.
divisor is k equal to some number, let's say c, or x, yeah, k equal to some number c. If you were to substitute c in for x, you get your remainder.
Got it.
Okay, so you can do this a couple of ways. You can just substitute that -2 in for x, and whatever you get out, you get your remainder. Or you can use synthetic division, and whatever your last number is your remainder. So do you want to see that on the calculator?
Yeah.
Okay. Now, this is my cell phone. Um, you can get a free app to get a TI-84. Okay, see that
Yeah.
icon right there? That's a free app right there. So you can just go to
Okay.
your app store and get a TI-84 put in your calculator. Okay.
Got it.
So
Yeah, that's what I'm gonna need.
yeah. Now each instructor is different. You may have an instructor that won't allow calculators on your cell phone.
Right.
So it's an instructor's prerogative. So you're just going to have to go with whatever the instructor wants. Okay, so all right. So there's a couple of ways you can do this. I'm just going to do the simplest way. There's other ways to do it, but I'm just going to go ahead and put -2 in wherever the x is and use parentheses. So we're going to put in 3 and then parentheses and -2, close it, oh, here it is. And then cube. So you hit the exponent button,
Right.
cubed. And then for the TI, see how it's up here raised? Can you see that?
Yeah, I can see that.
Um, you got to make sure that you get out of that exponent, so you have to hit the right arrow. And you see now it's kind of gotten bigger. The cursor's gotten bigger.
Yeah, the cursor got bigger.
Yeah, so you got to hit that right arrow to get out of the exponent. And then minus 6, and then open parentheses, -2, close parentheses, squared, hit the square button. Now, you got to be careful here because when you hit -2, you got to use this negative and then 2. But when you hit the minus for -6, the operation keys, you got to hit this one and then -6, okay? Okay, now when you hit squared, you don't have to hit the right arrow because it automatically goes out of the exponent. Okay, -4, and then open parentheses, -2, close it, +7. Okay, and I didn't even have to hit enter. Sometimes you have to hit enter to get the answer, but that's your remainder right there.
Yeah.
So
Okay.
if you were to use synthetic division, you should get the same remainder at the very end.
Got
Okay.
it.
Do you need to see synthetic division too, or are you good?
I can see the synthetic division part.
Okay. All right. So -2 is your divisor. So we don't need to change the sign. All right. And then you need a place for x cubed, a place for x squared, a place for x, and your constant. So you're going to use the coefficients. Okay. You put in the coefficients 3 for x cubed, -6 is the coefficient of x squared, -4 is the coefficient for x, and then 7 is your constant.
Right.
Okay? So you don't write out the whole polynomial like you would for long division. Okay, so this is kind of like the shortened version of long division, and they flip, instead of going up and over, right, they flip this division sign upside down. And then what you do is you drop the first number down to the third row. Here's first row, second row, third row.
Okay.
You drop that first number down, and you multiply the -2 times whatever the the third row is. So this is -2 times 3 is a -6, and you put that in the second row. Now the signs, if the signs are the same, you add. If the signs are opposite, you subtract. Here we have a -6 and a -6. The signs are the same, so we're going to add negatives and get a -12. Okay, we good?
Right. Yes, sir.
So now we're going to multiply the divisor times the bottom number again, bottom row. So negative times negative is a positive. 2 times 12 is 24, so that goes in the second row. 12. Okay, again, now this time, one number is negative, one number is positive, so you have to subtract. But you have to be careful because the bottom number is the positive is larger than the negative. But you got to remember that you're still subtracting. So you have to borrow the 2, right? And you get 8. You don't want to subtract 4 and say, you don't want to subtract 4 and 2 and get 2, right? Well, that's, it's not right. So this will be +8 because you've got more positive than negative, right? Okay. Now we're going to multiply -2 times 8, and we get a -2 times 8 is 16. So 7 and 16 is a negative 9. Okay, so something's not right here. Let's see. Negative 3 cubed minus 6 um, why is this not? Okay, something's wrong. Negative 6, negative 12. Oh, okay. All right. So 2 times 12 is 24. I put 12. So this should be 24. So now 24 minus 4 is 20. Okay, so that's really going to change things. So now negative 2 times 20 is negative 40. Okay, and then we get negative 33. Okay, there we go. Now we got it right. So you see the remainder theorem, verify, you can use the remainder theorem to check your synthetic division. And sure enough, my synthetic division was off because my remainder theorem told me I'm getting a different number. So I checked my remainder theorem number and it looked right. So I went back and I checked my synthetic division. Sure enough, I made a mistake and corrected it, and they both came out negative 33. Okay?
Okay.
Now, in the past, if you go on to pre-calculus and calculus, they use a similar method for factoring a polynomial like this, but using the remainder theorem was very tedious, and there's a much faster way. If you take any of my courses in pre-calculus, I show you a much faster way to do it. But this is all you need to know for right now. So any questions with that? So basically your answer is negative 33. Okay, that's your answer. You're just looking for the remainder. Okay, you're just looking for that number right there. Okay. Questions with that? Do you need to see the next one too? Oh, it says here, use synthetic division to decide whether the given number k is a 0. Now, if you put negative 2 into this polynomial and you get a 0 out, that means it's a 0. So in other words, what that means is wherever your graph intercepts the x-axis, that's a 0. So this means that this is some number x, we'll call it x. Y is 0, but it's some number x. So that's why they call it a 0, because it intercepts the x-axis and y is 0, and you get the other number x. So if you were to substitute negative 2 here and get a 0 out as a remainder, then it's a 0. Okay? Do you need to see that one? Okay. You're breaking up a little bit. I really couldn't hear what you were saying.
Oh, I was saying no, sir.
Okay. All right. 15 gets into end behavior. Do we need to go over that?
Yeah.
Okay. All right. Get another piece of paper here. All right. As far as the end behavior goes, when you have y equals to the leading term, ax to the n, if a is negative it flips or reflects it about the x-axis. Okay. If n is even, then it behaves like x squared. Well, x squared is even. Okay. This is even. So anything like if for squared, fourth, sixth, eighth, anything with an even power, it's going to behave like x squared. If n is odd, then it's going to behave like x cubed, such as 3, 5, any of the odd numbers, 3, 5, 7, 9, so on. Okay. For example, if we have, so like x squared goes up and up, right? If it's negative, it moves down and down. X cubed moves up to the right, down and to the left. So if you had something like y equals to x to the fifth, for example, plus 3x squared plus 2, let's say, you look at the leading term. And in this leading term, you look to see what that exponent is. Well, this is odd, so it's going to be, and it's positive, so it's going to behave like a positive x cubed. Okay, so it might come, so it's going to be it's going to end up and to the right, down and to the left. It could snake around, but it's going to end up and to the right, down and to the left. Okay. All right. Now, if you have something like y equals to, let's say, a negative x to the sixth plus 3x to the fifth plus 2x squared plus 5, let's say. Again, you look at that leading term. The negative is going to make it flip, right? It's going to make it reflect about the x-axis. And the leading term, the exponent is even. So in that case, it's going to behave like a negative x squared. So it's going to be down left, down right. So it could come up, it could go snake around like this, but it's going to end up down and to the left, down to the right, like x squared does. So this is known as the end behavior. So having said that, if this is, you look at the leading term, right? 6x to the 6th. Now that number doesn't mean anything, but the sign does. So if it's positive, x to the 6th, this is going to behave like a positive what?
Like a positive thing. The one.
Yeah, positive x squared, right?
Right.
So is it going to be A, B, C, or D for an answer?
I feel like it'll probably be B.
It's going to behave like positive x squared, right?
Right.
This is x cubed. This is x squared. This is positive x cubed. This is positive x squared. Negative x cubed. Negative x squared. Okay.
Got it.
You want to see another example? Well, let's
Uh,
see what we got. Let me see what the next one is. All right, number 17. You got negative x to the fifth. You just look at the leading exponent, leading term. So is that going to be, what's that going to behave like?
the leading term is a
Yeah, it's a negative x to the fifth, right? So it's negative, right? And it's to the fifth power. So is that even or odd?
So it's odd.
Yeah, it's odd. So it's going to behave like a negative x cubed, right? So which one of these n behaviors would behave like a negative x cubed? If this is a positive x cubed, right, then what would negative x cubed look like? A, B, C, or D?
Negative would be one thing now, right? It's not. So negative, yeah, the negative would be
Yeah, because this is a positive. See, let me draw this larger. Okay, y equals to positive x squared. Looks like this, right? Y equals
right.
to negative x squared opens down, right? Y equals to x cubed looks like this, right? Y equals to a negative x cubed is going to flip it. So instead of being up and to the right, it's going to be down and to the right. Instead of down to the left, it's going to be up and to the left. Okay? So you may want to go back over that on the later on. So that's why it's D. Okay? Do you want to see another example?
I'm good for now with that. I
Okay.
finally understood.
All right. So do you need to see 16? Use synthetic division to decide whether the given number is a zero. So in other words, if you plug
No, but can we look at 18 real quick before we go? I think
18, yeah. Okay, so let's look at the parent graph for a reciprocal function. Okay, y equals to 1 over x. Okay, it has vertical and horizontal asymptotes at x equals 0, right on the y-axis, and y equals 0, right on the x-axis. It has two curves, one in the upper right, one lower left. Okay, so it does the same. This transformations are the same for the reciprocal graphs. If you get y equals to negative x, okay, negative 1 over x, it flips it. Now, instead of the curve being up and the right, now it's down and right. Instead of being down left, it's up. So it flips it. It flips it. And you still have the same asymptotes, okay, with the negative. If you get y equals to 1 over x plus, let's say, 3, okay, that's going to make it go up 3. So it's like outside of the parentheses. So this is 1, 2, 3. So now this horizontal asymptote is here at y equals 3. The vertical asymptote did not move any. So you move the asymptotes first, and wherever those asymptotes go, the curves follow. So those curves hug along those asymptotes. Okay? So if this were negative, then it would move the graph down. Okay? If you have y equals to 1 over x minus, let's say, 5. This is like parentheses. Okay? So this will shift it left. I mean, right. I'm sorry, right. Because it's opposite, 5. So this will be 1, 2, 3, 4, 5. So here's your vertical asymptote, moves to the right. Horizontal asymptote does not change. So the curves go wherever those asymptotes go. Okay? We good so far?
Yes, sir.
All right. So now if you get a combination of the two, let's say y equals to 1, let's say, let's put a 2 in there. Let me start over. Y equals to, let's say, 2 over x plus 4, let's say, and minus 1. Okay? Well, the 2 makes it do like a vertical stretching, like as if you had 2x squared and made it stretch. Well, so that 2 really doesn't affect anything as far as what we're looking
Nah.
at. So this will make it shift left 4 and down 1. And this will stretch by a factor of 2. But really, it's not going to matter that much. Okay, so left 4, down 1. All right, so the vertical asymptote is going to shift 1, 2, 3, left 4, and down 1. So where this crisscross is, oh, okay, we're getting, all right, we're almost, but we're good. We'll finish. Where these asymptotes crisscross at is at the origin. Now the asymptotes crisscross at left 4, down 1. Well, the curves just follow wherever those asymptotes go. Okay? All right.
Okay.
So when we're looking at this, 2 over x plus 4, it's going to make that graph shift which way? The 2 just stretches it, but we really don't care about that.
So the graph's gonna stretch to the graph for that one. Since
Yeah, well, for stretching for this, what it does is it makes the curves further apart. But
okay.
they're not going to distinguish between something that stretches and something that doesn't. So you don't really need to
Right.
worry about that. So we're almost out of time, so I'll go ahead and tell you. It's going to shift like it's in parentheses.
Okay.
So it's going to shift. If it's down in the denominator, it'll shift like it's in parentheses. So it'll shift left 4. So this is increments of 2, 4, 6, 8, 10. So this will 2, 4. So it'll shift over here. And then it's not going up or down. So it's going to make it shift 1, 2, 3, negative 4. And didn't shift up or down, so it's going to do that. Okay, so it'll look something like that. Because of it's 2, it's going to make these further apart. That's all it's going to do.
Got it.
All right, find the horizontal vertical asymptotes. Horizontal, think of horizon, like the horizon. If you're looking off,
Yeah, like the
horizontal. Horizontal is at y. Horizontal always is the y. Y equals to 1. Vertical is always goes through the x-axis, so that'll be x equals 3. Okay, and I believe that's all we wanted. Let me double check that. Yeah, that's all they wanted. Okay, and then 20, sketch the graph. It's going to be like x cubed, but that minus 4 is going to make it do what?
-4 is gonna make it go down.
Down 4, yeah. So the parent graph, right? This is x cubed. So it's going to make this point go down 1, 2, 3, -4. So it'll do that. Okay?
Okay.
And that's it.
Thank you, though.
All right, you're welcome. Let me know if you have any other questions. And have a
Okay.
good day.
Okay.
All right, and that's all